cases in 6.4, Unit 6.4, special cases and word problems. We're going to go over the different kinds of cases you see when we do systems of equations by all three methods: graphing, substitution, and elimination. There are others, but you'll learn those in Algebra 2, as I said before. So we're going to start with special cases when we're dealing with graphing. Now, when we're graphing a system of equations, you end up with three types of outcomes. All right. The first one we already know. You graph and you get two distinct lines, such as this one and one right here. And we look for that point of intersection, and we get a point. And then that's our answer, in this case, 1. So anytime we have what are called intersecting lines, we end up with one solution. And that's what we had beforehand. Intersecting lines, one solution. All right. And that's what we covered in section 1. All right. The next thing is if we get two lines that are parallel. And you'll notice parallel lines. Well, what do they never do? Well, they never intersect. So is there any answer that's going to satisfy both lines or both equations at the same time? The answer is no. So if we end up with parallel lines, you have no solution. There is no answer that will satisfy both at the same time. So parallel lines, no solution. And then our third case is if we get one line and immediately the other equation graphs a line right on top of it. Basically, we're graphing the same line. And in this case, how many times do they intersect? Well, they intersect all the time. So our solution is there are infinite solutions. Because they're intersecting all the time, no matter what number we plug into either one, they will always work at the same time. So, going back, with graphing, if we have intersecting lines, there's one solution. If we have parallel lines, there are no solution. And if we have the same line, two lines graphed one on top of the other, we have infinite solutions. All right, so those are our situations we're dealing with when we deal with graphing. All right, so let's move on to substitution. All right, we know with substitution, we are supposed to solve one equation for one variable. So either x or y, and it doesn't matter, but always try to pick the easier one, which one's alone by itself and positive, or just alone, makes it the easier one to solve for. And we plug it into the other equation, and we get a value for that variable, and then we solve for the other variable. We did that in section 2 on this, and we got our answer. So we already know how to get one solution. But let's look at what we have when we get the other types. All right. So x plus y equals -2. I'm going to solve this equation just for x. So what I'm going to do is I'm going to subtract y from both sides. And I get x equals -y minus 2. And I always tend to put my variables first just because I like that. All right. So I'm going to take that and I'm going to plug it into my second equation, -3 for x. So we get -3 minus times -y minus 2 minus 3y equals -3. Distribute 3y plus 6 minus 3y equals -3. And if I combine like terms, I have 3y minus 3y, which ends up being 0. So this ends up being just 6 equals -3. You'll notice 6 equals, that can't happen. There's no more y's. I don't have any y equals. There's no x's. There's no variable at all. But I end up with an untrue statement. 6 equals -3. So with that being said, since that's an untrue statement, there's no way this can happen. We get no solution. And there's my answer. Untrue statement. It's not possible. So we get no solution as my answer. All right, let's look at the second one here. 2x plus 16y equals 0, and x plus 8y equals 0. Well, I want to solve for x in the second equation, just because it's already by itself. And we get x equals negative 8y. All right, I'm going to take that, plug it in. 2 times negative 8y plus 16y equals 0. So I get negative 16y plus 16y equals 0. And in this case, combine like terms, I get 0 equals 0. Well, again, I do not have any more variables. There's nothing left. There's no x's, there are no y's. But I do have 0 equals 0, which is a true statement. And since that is a true statement, and it's always true, 0 equals 0, I know I have infinite solutions. Now with substitution, you'll see that we get numbers that, 2 unlike number 6 equals negative 3 is no solution. It doesn't always end up being 0 equals 0 for infinite solution. It could be 5 equals 5, negative 7 equals negative 7, 1/2 equals 1/2. It doesn't matter. As long as it's a true statement, there are no variables left over, and that's what we end up with. Then it is infinite. So with substitution, when we substitute in, all of a sudden we have no more variables left. If we have a non-true statement, it's no solution. If we have a true statement, it is infinite solution. And so that always holds true with substitution. All right, so let's look at the special cases with elimination or linear combination. All right, remember with this one, we want to multiply or divide our systems, one or both, to get a common coefficient that is opposite in each thing, so we can eliminate at least one of the variables. We're going to use basically the same, so we know what our answer should be. However, we're going to just make it easy. So in this one, we have x plus y equals negative 2 and negative 3x plus minus 3y equals negative 3. Well, we see x, they're all both opposites sign already, but we need one to be 3. So I'm going to multiply the top version by 3. And so that gives me 3x plus 3y equals negative 6. And then we have negative 3x minus 3y equals negative 3. So at this point, we add our two equations together. And we see that negative 3x minus 3x, that's 0. 3y minus 3y, that's 0. So we got 0 plus 0 equals negative 6 plus negative 3, which is negative 9. So we end up with 0 equals negative 9. Again, that is untrue. That is not possible. So in this case, since it's not possible, we know it is no solution. So we see with elimination, what we're going to end up with is one side will be a 0, the other side will be a number that is not equal to 0. So when we get this, when we do elimination or combination, that if you get 0 equals some other number, and it's not possible, we know it's no solution. Now, that doesn't mean it's like 2x equals 0. That means x is 0, and that actually is a value. We have no variables left. They're all canceled out. They're all subtracted out. At that point, we will get no solution. All right? So again, we're going to use the same one we used in substitution. 2x plus 16y equals 0. X plus 8y equals 0. We need to get something to be opposite. Since the x's are already 2 and 1, but one's positive, one's negative, I'm going to multiply the bottom one by negative 2. So that gives me 2x plus 16y equals 0. And then I get negative 2x minus 16y equals 0 as well. We add those together, 2x minus 2x is 0. 16y minus 16y is 0 equals 0. So we end up with 0 equals 0. So again, we see 0 is the same. That is a true statement. So therefore, it is infinite solutions. So again, we see with elimination, you'll always end up, when we do this, when we get a special cases, you get 0 equal to something. All right. So 0 equal to some other number than 0, no solution. With 0 equal to 0, it's a true statement, infinite solutions. And that always happens with elimination. Do not confuse that with substitution. Substitution does not necessarily have to have 0. Substitution can have any numbers. If it's a false statement, no solution. if it's a true statement infinite. So it doesn't have to be 0, 0. The combination or elimination one will always have that, right? So again, remember, special cases, you either have a solution, which is one solution, which is what we've been doing in the first 3 sections, or if you have one of the special cases, you're going to either have no solution, an untrue statement with no x's or y's there, or you're going to have an infinite solution, which is a true statement, but again, no variables are present, either no x's or no y's. Or if you're graphing, you end up with either the parallel lines or the same line. All right, so let's move on to word problems, all right? Applications. We're going to take word problems and apply systems. And these are actually used a lot when you're trying to find things that are the same or break-even points. All right, sorry about that. Define the variables. So to do this, when we solve word problems, one, you want to define your variables, tell what letters you're using and what they stand for. So if you're going to use x and y, say x is equal to this amount, y is equal to this, whatever our unknowns are. You don't have to use x and y. You can always use whatever letter corresponds. So if we're doing things like hot dogs and pizza, you can use H and P. Very easy to understand. H is for hot dogs, P is for pizza. 2, you want to set up your equations. And remember, there's always going to be 2 here. All right, since we're doing systems, there's always going to be 2. And the third one is we solve. And you can solve using any method you choose. Preferably not graphing, because a lot of times when we're dealing with values and stuff, we're going to end up with numbers that are way, way, way off the graph, and they're very hard to do by hand. We're going to pretty much stick to substitution or elimination, and most of the time I'm going to probably just do elimination unless substitution is really easy. It just depends on what we're doing, all right? But I'll tend to stick to those 2, substitution and elimination, all right? So again, define your variables, what do they represent, set up your equations, and solve. So let's take a look at one. Number 1, a health food store mixes granola that costs them $4 per pound and raisins that cost them $2 per pound, and together to make 25 pounds of trail mix. How many pounds of raisins should they include if they want the trail mix to cost them a total of $80? All right, so a lot of information in here, but let's start out with what are unknowns. We want to know how many pounds of raisins they want to do. So we know raisins, one of our other things. What other ingredient do they need for trail mix? Well, we look up here and we see that it is granola. We know it's granola and raisins. So if you want to use G and R or X and Y, it doesn't matter. I'm going to use G and R. G for granola and R equals raisins. And now these are pounds of each, right? Pounds of granola. So if you want to put pounds of granola, pounds of raisins, and LBS is pounds shorthand, right? So those are pounds of granola, pounds of raisins, R and G. All right, so we have to set up our 2 equations at this point, right? Well, when we do word problems, and 90% of the time or even more, when you're looking at these problems, you have 2 problems there mixed in together. You have a total amount where you basically take your 2 things and they add up to be a total, and then you have a monetary value where first thing costs something, second thing costs something, in total they cost all this together. So I always tend to start with the total, or what the 2 products, what are we looking at in general. So we're looking at G and R, and we know that they together make 25 pounds of trail mix. So I know that if I took the amount of granola and I added the amount of raisins, that's going to equal 25. G plus R equals 25. All right, so there's my total. So I've taken care of the amount of granola plus the amount of raisins. The pounds of granola plus pounds of raisins equals 25 pounds total. Then I can move on to my value, right? What do each cost? We know that granola costs them $4 per pound, and we know that raisins cost them $2 per pound. So we know for every granola pound, it costs me $4. For every raisins, it costs me $2. And then I spent a total of $80. So now you'll notice that right now I have a system of equations. I have 2 equations. Both have G and R. Both have an equal sign to a number. So now we can use any method we want. We can use substitution, we use elimination, we could use graphing. I'm not going to use graphing because even if I solve for G or R, you have to determine which one's your X and your Y. Don't want to do that. I'm going to use elimination. And I am going to eliminate the R's. 1, it's the easiest number to multiply by. And 2, all I have to do is multiply the top version by -2. So by doing that, what I end up with is -2G minus 2R equals -50. And then I have 4G plus 2R equals 80. And I'm going to add those two together. -2 plus 4 is 2G. 2 times the granola equals, we see our R's cancel out. -50 plus 80 is 30. So I get 2G equals 30, divide both sides by 2. And we end up that granola is 15. So there are 15 pounds of granola, but that's not what I'm asking for. Question asks, how many pounds of raisins? Now you could have done it another way and gotten what the raisins were. So we know there's 15 pounds of granola. How many pounds of raisin? Well, we know that raisins plus granola is 25. So if we know granola is 15, 15 plus R equals 25, we now know that R is 10. So there are 10 pounds of raisins. So there is my answer. But we always could ask, how many pounds of granola, and you now know it's 15 as well. So it's 15 pounds of granola, there are 10 pounds of raisins. So in the answer, how many pounds of raisins should they include? It's 10 pounds, right? And we could always ask, if you wanted to, an extra question, how much does 10 pounds of raisins cost? And it's $20. It's not bad. It's a lot of raisins for $20. All right, let's try another one here. A group of 40 children attended a baseball game on a field trip. Each child received either a hot dog or a bag of popcorn. Hot dogs were $2.25 and popcorn was $1.75. If the total bill was $83.50, how many hot dogs were bought? So we're looking for the amount of hot dogs. All right, so let's go back again. Identify what we're doing. In this case, hey, it's hot dogs and popcorn. Hot dog, popcorn. And everyone buys one or the other. So I'm going to do H for hot dogs. H for hot dogs. And I'm going to do P for popcorn. All right. So again, when we do our equations, we have a total and we have about monetary value. So let's start with our total one. Total, we know that a group of 40 children, and each child received either a hot dog or a bag of popcorn. So one got one and one got the other. 40 children, there's got to be 40 hot dogs and popcorn together. So we know that H plus P has to be 40. Now we do the monetary one. We know that hot dogs were $2.25, so $2.25 per hot dog, plus $1.75 per popcorn equals $83.50. And so there's my monetary one. So now I have my two equations. Now in this case, again, we could do elimination. We could do substitution. I'm going to do substitution on this one, and I am going to solve for H. I'm going to solve the top one for H. So I get H is equal to 40 minus P, or negative P plus 40. So I'm going to take that and plug it into my second equation. So 225 times 40 minus P plus $1.75P equals $83.50. All right, 225 distributed to both 40 and negative P. 225 times 40 is 90 minus 225P plus $1.75P equals $83.50. Combine like terms, we get 90 minus 0.50P equals $83.50. Subtract 90. You get negative 0.50P equals negative 6.50 divided by negative 0.5. And what we end up with is P is equal to 13. So we sold 13 bags of popcorn. But we are looking for the number of hot dogs. So in this case, find the number of hot dogs. We're going to take H plus 13 equals 40. In our case here, H equals 27. So there are 27 hot dogs, and that's my answer. Hope you understand. Make sure you practice this, and we will do more later.